All right, here's day 5. So we're going to be putting it all together now, right? So doing all of the previous work, but just in a different context. All right, so here's another example. So given this function, find the average velocity and the instantaneous. So this would be a solid screencast to watch before you take the quick check, but also it's just really reviewing everything we've learned already. So the average velocity. So we find average velocity by the slope equation. Okay, slope equation. So the average velocity, so V average is just going to be S of T2 minus, I'm sorry, this is D, because that's the functions in terms of D, minus D of T1 over T2 minus T1. Okay, so let's go ahead and let's plug in. So this is going to be D of 5 minus D of 1 over 5 minus 1. So let's plug in. So 3 times 5 squared minus 3 times 1 squared over 4. 3 times 25 minus 3 over 4. So 75 minus 3 is going to be 72 over 4. We can simplify this. Let's see, 18. So it should be 18. Let's see, it doesn't give us units, so that would be it. We can just say 18. Okay, so this is the average, and what we want to know is what is the instantaneous at 4 seconds. So the average is 18, but let's go ahead and let's see what is the actual value at 4 seconds. So to find the instantaneous, we say V of t, so let's do V of 4 is going to be the limit. Let me zoom in a little bit. V of 4 is going to be equal to the limit as h approaches 0. Dang it, I keep doing that. D of 4 of f of 4 plus h minus f of 4 all over h. This will be the limit as h approaches 0, so we're going to be plugging in 4 plus h in for t. So we have 3 times 4 plus h squared, and we're subtracting 3 times 4 squared all over h. Alright, so the tricky part here is knowing how to FOIL this together. You're doing 4 plus h times 4 plus h. So you end up with 16 plus 4h plus 4h, so that's plus 8h plus h squared. And then we're going to be distributing out 3. So this is going to be, let's see, 3 times 16 is 48. Plus 24h plus 3h squared minus 4 squared 16, so minus 48 all over h. Right, good, good, good. That cancels out. And then if you wanted to, you could say, okay, now that I'm left with 24h plus 3h squared, you could just do this one step. So then we have the limit as h approaches 0 of 24 plus 3h. Well, that turns out to just be 24. Awesome. So notice that this is different. This is different than if I just plug 4 in. So here, this is the distance. This tells us how far we've gone. But if we're trying to find velocity, that's a change in distance per time. So just plugging in 4 gives us how far we've gone, but it doesn't tell us how fast we're going at that moment. All right, and then we can compare the average between 1 second and 5 seconds is 18, but at 4 seconds, we're going 24 units per second, or whatever, yeah, seconds, units per second. So what this tells us is before 4 seconds, we had to be going slower than 18 for the average to be 18. All right, section 7. When an object's thrown straight down, the total distance y falls can be modeled by this equation. T is in seconds, the initial velocity is in feet per seconds. If an object thrown straight down from a height of 816 feet takes 6 seconds to hit the ground, what was the initial velocity? Okay, so we're just solving for it. Let's go ahead and let's plug in everything that we know already. Y is the total distance the object falls. So let's see, it takes 6 seconds to hit the ground, starts at 816 feet. So that means it went 816 feet is equal to 16. We know our time is 6 seconds. Plus V naught, you know what? Let me rewrite this. Why don't we solve first and then we can plug in. So I'm going to get V naught by itself first. So I have y minus 16t squared divided by t is going to be V naught because I moved this guy to left side and then I divided by t. So my initial velocity is going to be my y minus 16 squared. So I'm just rewriting it all over t. Plug in our values that we know. So since we started at 816 feet, we ended the ground, that total distance of 816. It took 6 seconds, so I'm plugging in 6 for t. And let's see what we get. Alright, so 16 times, well, 6 squared is 36, is going to be 576. And then add those two together, you get 240. Divide by 6, you get 40 feet per second. Okay, so we start with 40 feet per second. What was the average velocity of the object? Okay, so over this 6 seconds, let's find the average. So so V average, see our function. So we say f of t2 minus f of t1 over, over t2 minus t1. So we're going from 0 seconds to 6 seconds. That is our domain. So we want the average velocity over this total time. So this means we're going to be taking f of 6 minus f of 0 over 6 minus 0. Awesome. All right. So let's go ahead and let's plug in. Over here, I'm going to plug in f of 6. So it's going to be 16 times 6 squared plus, let's see, our initial velocity we solved for it was 40 times our time of 6. So we said 16, okay, so that was 576 plus 240 gives you 816. So not too surprised, because that is the total distance that we traveled. So at 6 seconds, we traveled 816 feet. Minus, if we plug in 0, f of 0 is going to be 0. Because you have 16 times 0 squared. And then adding 40 times 0, okay, that's just 0. Over 6. So if I take 816 divided by 6, we will have the average velocity. Alright, so 816 divided by 6 is 136, and it's in feet per second. Cool. Alright, so just a little like DIMS test, does it make sense? We start at 40 feet per second. We're going down, right? It's accelerating, it's getting faster and faster. The average is 136 feet per second. Since we start at 40, we know how much we end with is going to be more. So it has to be more than 136. So the next question says, what was the object's velocity when it hit the ground? Okay, so we want a single point of time. This is going to be the instantaneous velocity when it's hitting the ground. What's your speedometer at that moment? So we're going to go ahead, let's see. V of at 6 seconds. What is the actual velocity at 6 seconds? Well, we know it has to be more than 136 because that was the average, and we started with 40. We could kind of guess, maybe 180 or so, but let's go ahead and let's actually figure out the actual number. Okay, so we want f of 6 plus h minus f of 6 all over h. So let's scroll up so I can see my equation. All right, so I'm wanting the limit as h approaches 0 of 16 times this 6 plus h squared plus, let's see, our v naught, our initial velocity was 40 times 6 plus h. So this question kind of sucks in the sense that if you miss part A, B and C are going to be off because you're using the value you found in part A. This is why it's important to show your work, so I can give you points for carry through error. Even if you did part 1 wrong, if you did the correct method in part B and C, I would still give you credit. So make sure you show your work. Alright, so 40. Okay, so we are plugging in 6. 16 times 6 squared plus 40 times 6 all over h. Oh, come on. Alright, so limit as h approaches 0. Okay, so we've done this before. So 16 times 36, and then plus 16 times 12h, plus 16 times h squared. Yeah, plus 40. Okay, so that's plus 240, plus 40h, and then we're subtracting 16 times 36, and then we're subtracting 240 all over h. So this last part was me distributing this out, and since I knew this was canceling, I'm not going to bother doing the math right there. Okay, cross out. All right, we're simplifying a little bit. Limit as h approaches 0, change colors just so we can be clear. 12 times 16 is going to be 160, 192 h, plus 16 h squared plus 40h divided by h. Oh, did I just not? Oops, I should have simplified that. Whatevs. Forgot that these two can be combined. 40 plus 192 is going to be 132. 132 plus 16h as h goes to 0, so it's just going to be 132 feet per second. Oof, that's not what I want to do. All right. So this is the velocity when it hit the ground. Nope, I definitely did some math wrong. It should be more. Yep, realize my issue. 192 plus 40 is going to be 232. So this is 232. Okay, so that's right. Because remember our, since we started at 40 and we said our average was 136, I was like, okay, so it's got to be around 180 or so. It's got to be significantly more, which it is 232 feet per second. So the homework is the extra practice worksheet. Yes, I already uploaded the solutions for it, but try your best to do it yourself.